Hi children, welcome back to Max class, and this is the third session for the fourth chapter, Squares and Square Root. Hope you people are enjoying these shutdown with more technology at home, and I'm happy to see all your assignments in the technological and digital form. Very nice, my dear children. Let us have a thought before getting into the session. The only person you should strive to be better than is the person you were yesterday. You can compare only yourself. We don't like to be compared with others. Exactly, my dear children. So let us compare ourselves, how we have improved from yesterday and today. There should be some learning every day to show our improvement. Okay, children? So take this learning an enjoyable one and make the best. Okay? And this is a new way and we do enjoy it. In the beginning, though we had some toughness, now I believe you would have all adapted to this digital mode of learning. Okay, children, before getting into new concept, let us recall all the things that we have learned so far. Come on, list out all the properties of square numbers. We have listed few properties. Now, first tell me the properties that deals with the unit digits. What cannot be the unit digit? What your numbers cannot be the unit digit of a square number? Got the answer? Yes. None of the square number end with 2, 3, 7 or 8. What happens to the square of a number ending with 9 and 1? Surely it will end up with 1. If a number has 1 or 9 in its units place, then its square ends in 1. Then next property, it also deals with again unit place. Hope you would have guessed it. Number ending with 6. Then their square will have either 4 or 6 in its units place. When a square number ends in 6, that is, if I square a number ending with 4 and 6, surely that units place will be 6. Then square number can have only even number of zeros at the end. Okay, all these four properties deals with the units digit of a square number. Is it clear, my dear children? Now let us list out the property based on shape. Got it? What is that? What shape were we discussing while we were talking about square numbers? We should know about triangular numbers. It can be written as sum of two consecutive triangular numbers. Two consecutive. Next number can be added to get a square numbers. Come on, say the sequence of that triangular numbers. 1, 3, 6, 10, 15. It keeps on going. Okay, children, you know how to get the triangular series. Then all these next three properties will have the letter N in it. Okay, with this subdivision, try to have all these properties in your heart. Okay, if I have to find the square of two consecutive numbers, it will be 2 squared and 3 squared, and we can find the numbers of non-perfect square between them. How many non-perfect square numbers will be there? 2n. Is it clear? Between 2 squared and 3 squared, I will have 4. For between 3 squared and 4 squared, I will have 6. How did I got? I multiplied that first number that I squared now. 3 squared and 4 squared means 3. That 3 should be multiplied by 2 to get the number of non-perfect squares. Hope you remember. The next property is sum of n odd natural numbers. We did addition without actually adding it. We got the solution without actually adding using the formula n squared. There will be square here. It is hidden behind my. Next one. Sum of any square number can be written as sum of two consecutive numbers. Again, this is one formula that you should remember, my dear children. N squared minus 1 by 2 plus n squared plus 1 by 2. You may think, why this sudden formula? We do have this derivation of all these formula, my dear children. But then now it's enough for you, more than enough. If you remember this to answer the MCQs. The product of two consecutive even or odd natural numbers is always 1 less than the square of the number between them. This also deals with n squared minus 1. Okay, my dear children, today let us see a new concept, but you are familiar with that. Can you say, who is this? This is a great mathematician. Just to look around the things that is there near him and find who he is. Hope by this time you would have got an idea after seeing this. Got it? What is this? It's a right-angled triangle. And what did he give us? He is a Pythagoras. And what did he insisted on? He gave us a very famous theorem, Pythagoras theorem. What does it states that? Always this Pythagoras theorem, he dealt with a special triangle. It's a right-angled triangle. This right-angled triangle, 90 degree. One of the angles should be 90 degree. What did he conclude? Very good. Square of this hypotenuse. The longest side is the hypotenuse. If he square it, it is equal to this hypotenuse. This is hypotenuse. HY. I just write hypotenuse. And these are the two other sides. If he square this, it is equal to sum of addition of other two sides square, sum of squares of other two sides. See here in this picture, if I form a square with this hypotenuse, this is hypotenuse here. Okay, and how many squares are here? 1, 2, 3, 4, 5. 25 squares are here. And here 16 and here 9. If I add these two, I get 25. That's the beauty he found out. He found that beauty in triangle, right angled triangle. Okay, my dear children, if this is going to be 5, no? 5 squared. This is equal to 4 squared plus 3 squared. This is 5, 4, 3 forms the special category. See here 5, 4, 3. 5 squared is equal to 3 squared plus 4 squared. Whatever he has here now, I have written here. And similarly, if I have the length of this hypotenuse as 10, then 10 squared will be is equal to 6 squared plus 8 squared. Similarly, if I take a triangle with a few other number, I will get many other combinations. They will occur as a triplet. You know, double. If they occur in, like a pair of scissors, pair of socks, pair of spectacles. These three are always triplets. We give a special name to this as Pythagorean triplet. Can you find more such triplets? Yes, we can find here. But it's not very easy task to do it as such by calculating every time and finding it. Or you can draw and find it. Of course, we can find it. But this man has gave us a very easy thing to find it. He found that if I substitute the value for m, I can get a triplet. Triplet in the sense 3 numbers. So that it satisfies the rule that the biggest number square will be equal to the other numbers square, then sum it. Okay, they are 2m, m squared minus 1 and m squared plus 1 forms a Pythagorean triplet. So in this exercise, you should know what is Pythagorean triplet. This is the basic definition, my dear children. Pythagorean triplet is got by the general form. What is this general form? This should be in your heart every time. Okay, as you say the second table should be in your heart. How will you get the Pythagorean triplet? 2m, m squared minus 1 and m squared plus 1. Keep repeating. Make a note of this in any paper and stick it onto the wall so that you keep on seeing this every day and you will not forget it and it will get into your heart. Okay, my dear children, 2m, m squared minus 1 and m squared plus 1. Let us see how he got it. If I have m is equal to 3, I have to find 2m. 2 into 3, 6. Then I have to find m squared minus 1. m squared minus 1, which is equal to, in the place of m, I have to substitute 3. So 3 squared minus 1, 3 squared is 9. This minus 1 as it is. 9 minus 1, 8. So I got 6, 8. Then I have to find m squared plus 1. Okay, here I subtracted, here I should add. So surely what will be the answer? 10. It's very simple, my dear children. It's just of 3 steps. You have to find 2m, m squared minus 1, m squared plus 1. So what is the Pythagorean triplet here? 6, 8 and 10 are the Pythagorean triplet. I have done one more problem also for you. You have to find it and you can work it out on your own. So 8, 15 and 17 is another Pythagorean triplet. Very simple. In the place of m, write the number. It can be any number. I have chosen 3 and 4. You can go in for 100, 200, whatever you wish you can get it. Okay, all those are Pythagorean triplet only. Now let us see an example from your book. Write Pythagorean triplet whose smallest member is 8. Okay, so what is the general form to get the Pythagorean triplet? 2m, m squared minus 1, m squared plus 1. If you write this, it is easier for you to find the answer. Okay, and they have given one number out of the triplet. I have to find the remaining 2 numbers. For that, I am going to first check this 8 with m squared minus 1, whether it is suitable to m squared minus 1. I don't know among these 3 numbers which is going to be 8. I chose m squared minus 1 to be 8. Then minus 1, when it goes from left hand side to right hand side, it becomes plus 1. So m squared is equal to 8 plus 1. M squared is equal to 9. Here m squared is equal to 9 can be written as 3 squared. So what will be m? Here m is equal to 3. So I have to find 2m now. I considered m squared minus 1 as 8 and got the answer as 3. M is equal to 3. Then I substitute here 2 into 3, 6. Then I have to substitute in m squared plus 1 as m is equal to 3. Just now I got the value of m is equal to 3. Okay, 3 squared is equal to, m is equal to 3. 3 squared, 9, 9 plus 1, 10. Now what is the Pythagorean triplet? Immediately you will say 3, 6, 10. My dear children, be careful. You should get the values of m squared minus 1, 2m, m squared plus 1. So I can say 6, 8 and 10. Okay, here I too have made a mistake. It should be 6, 8, 10. This is the general error, human error, my dear children, because our eyes falls on the things that we find now recently. Okay, so be careful. It is 8, 6 and 10. Do you think 8 is the smallest in this combination? 8, 6 and 10. 8 is the smallest? No, it is not the smallest. So I should not take m squared minus 1 as 8. So what should I do? I will go in for 2m is equal to 8. 2m is equal to 8. So what is equal to m? This 2 is in multiplication. So when it comes here, it comes in division. So I get m is equal to 8 by 2, which is equal to 4. So I got 2m value. What are the remaining values I should find now? M squared minus 1 and m squared plus 1. Only 2 values I have to find. Okay, my dear children, it is a very simple thing. Only 3 steps. You will deal with 2m, m squared minus 1, m squared plus 1. It is in your hands to execute in any order. Either 2m or m squared minus 1 or m squared plus 1. But then I will give you a clue. M squared minus 1 is equal to 4 squared minus 1. Instead of m, I have to put 4, not 8. You will make even this mistake. You will start substituting 8 here. Just now we found the value of m is equal to 4. Okay. So 4 4s are 16 minus 1, 15. Similarly, you will find m squared plus 1. Here subtraction, here addition. So what will be the answer? 17 is the answer. So now see 8, 15, 17. 8 is the smallest number. So our condition is satisfied. So the required triplet is 8, 15 and 17. I can easily say that, my dear children, 2m will be the smallest number. M squared plus 1 will be the biggest number. Okay, whenever they give you the value of smallest number, start with 2m. If they give you the greatest number, start with m squared plus 1. Okay, my dear children, no need to have a trial and error method. But then I showed you all these things to have a good idea. Okay, my dear children, let us continue in the next video.